starting now.
Hello, everyone. My name is Susan Marlow, and I will be your moderator today for our webinar. We've got some great information to share with you, and we're very excited that you joined us. We appreciate your time, and let's get started. We like to start everything with a safety moment, and thought it would be very appropriate to have a safety moment about flood prediction and or flood warnings. And so sometimes it's hard to know what the difference between a warning and a watch and an advisory. So warnings are things, are floods are imminent, and you need to be prepared and get out of the area if you're in a flood warning area. Flood watch is they're expecting something to come, and then an advisory is just saying that it could come, but that you need to be prepared. So the message here is to be prepared and be always watchful for those incoming storms. As I said, my name is Susan Marlow, and I am the Director of Client Solutions for our innovation office at Stantec. And I have two very accomplished professional ladies with me today that I'm happy to introduce. Katherine Osborne is going to be with us, and she's going to talk a little bit about FEMA's Risk Map initiative. And Katherine has over 13 years of water resources engineering and experience with FEMA flood mapping. Brandy Little is our Director of Product Management, and she is the product manager for our Flood Manager product that we're going to talk about today. And she also has 17 years of experience with the FEMA Flood Map program, and so we're very pleased to have them with us today. Our featured topics today are going to be FEMA's, the future of FEMA's Flood Risk Data Initiative. Katherine's going to talk to you a little bit about that, and we want to talk about what that means to you and how we can help. Then Brandy will do managing flood risk, and we'll do a live demonstration of our Flood Manager product and give you some of the ideas of how we've been able to help customers or clients with those. And then we'll give you some case studies and about how you can get ahead of this initiative that's coming. I would like to tell you that we will be recording this today, and so I would like for you to have your questions and ready, and you can put those in the Q&A. Go ahead and do those at any time, even though we're not going to answer the questions until the very end. We will also be providing you a certificate for professional development hours if you would like to have that. And then, as I said, we're recording. We'll provide that to you at the very end. Again, we're answering questions at the end, and let's let Katherine take it over from here.
Great, thanks, Susan. So FEMA's Future of Flood Risk Data, or FFRD, refers to an initiative to modernize and enhance FEMA's flood hazard and risk data, to benefit a wider array of program stakeholders and users, and to provide a more comprehensive, efficient, accurate, consistent flood hazard risk data set. Traditionally, we've developed the 1% annual chance of flooding as the basis for individuals and communities to understand their risk and to make decisions, rather than a more comprehensive picture of flood risk. So as more extreme events are becoming the norm, this comprehensive need is even greater. FFRD also directly complements Risk Rating 2.0. So if you aren't familiar with Risk Rating 2.0, it's FEMA's updated pricing methodology for insurance premiums to establish an individualized approach to risk assessment. So in the past, risks was only assessed by location within the floodplain and property type, whereas Risk Rating 2.0 uses new data, new flooding models, and new technologies to categorize risk. So FFRD has 4 key objectives. First, you're going to see a shift from binary to graduated risk analysis, or moving away from that in or out of the floodplain notion and really focusing on a quantified risk. Second, FFRD plans to modernize the management and delivery of flood hazard mapping with the latest tools and resources. So the private sector, state, local, tribal, and territorial entities would assist in the development and deployment of these tools so that they're more involved. And the updated, easily accessible flood hazard data will better inform stakeholders for effective decision support, ultimately improving mitigation and insurance actions. So the underlying engineering foundation, which supports both FFRD and Risk Rating 2.0, are probabilistic and two-dimensional analyses. So this is a shift from the traditional one-dimensional or binary analyses. And funding these analyses, which advance FFRD and Risk Rating 2.0, are a main priority and objective of FEMA's Risk Map program. So you've probably seen a lot of 2D and 2D BLE modeling taking place. So why does the shift to 2D and probabilistic modeling matter? So these types of data and models analyze a larger area. So there's an increased number of hazards, scenarios, probabilities, durations, and intensities, which provide more detailed and reliable results, especially in complex flow situations. So traditionally, one modeling uses cross-section data along main streams and tributaries, whereas 2D applies mesh-based analysis to model all the flooding sources within the mesh. And then 2D analysis can model both fluvial and pluvial flood hazards. So, however, these models do come with challenges. So instead of minutes to run a model, we're now talking hours and even days. And shown here is an image of a typical 2D model for a recent FEMA project showing a runtime just of one model for 19 hours. And the worst part is that you don't really know how long a 2D model is going to take until you actually set it up. So these models are larger, more complicated, and therefore are going to take more storage and time to develop, to calibrate, process, review, and even share. So I'm going to turn it over to Brandy Little, who is our Director of Product Management, and she's going to detail how Stantec's product Flood Manager can help alleviate many of these challenges.
Hello, how are you guys doing today? Hope you're doing great. I'm going to share my screen here. So Flood Manager is our product that we have developed. As Katherine said, these very large running models are super time consuming in HECRAS with the sequential plan running. And so we have worked on a process to be able to run not only the models in parallel in the cloud, but also to run plans in parallel in the cloud. And so this is Flood Manager UI. When you come in to the user interface, it is organized by project. So all users are assigned to a project and models can be created within that project. Only the users assigned to the project have access to see those models and work on those models. So it has base user permissions built in. And so when you come in, you're actually able to select on the project and select to create a model. I'm going to step through actually setting up a model for you all today. So we're going to do demo model as our model name. We have the user interface where the files can be uploaded. So the engineer is still doing the modeling on their local PC. They are setting up the model, and then when the model is ready to run, they're dragging and dropping those files into the UI. As these are uploading, you can go ahead and fill out all the parameters. We do have model type here, and there's some additional selections. We have a quality report only, which I'll go into detail further in the presentation. We have a flood interval script, which is some post-processing to combine depth grids into a flood interval raster. So I have some base post-processing built in. So we're going to give our model a description. This description can be anything the engineer would like it to be, just to help them identify that model run. We do have compute size where the user can select the compute that they would like to use to run the model. And then the run description, we'll do run 1. This can be updated each time because after the model is run, if you determine that you need to change a geometry or change a file in the model, that can actually be revised and then replaced, and you can change your run description and then kick off a new model run of that model. We do currently support HEC-RAS versions 507 through 6.3.1, excluding 6.1. And then you're able to select which plans you would like to run. For this, we'll run all 3 plans. If you select to just run one plan, that's going to be a typical run. Your benefit is really going to come into when you have multiple plans to run at the same time. We do also have some additional post-processing to export out grids. So we have the depth grid, the velocity grid, and the water surface elevation grid. When those are selected, it will prompt you to select a projection file to be used for those grid exports, as well as your render mode. We have a couple options that are available in the HEC-RAS UI there. This does not have to be set up in your model. This can be executed even if you haven't selected those to be created in the model. Running plans in parallel, you always want to ensure this is checked because this will actually run these in parallel instead of sequentially, and that will really speed up your process. And then we do have the option to run a post-process quality report, and I'll show you guys. We'll queue this model off to run, and we'll take a look at one of these quality reports. So when the model is complete, it will run the quality report check. This is a global kind of check to bring everything into one central location to just really help facilitate getting to that final model. So we do include the percentage error volume accounting. We include all the plan information and settings that were set up in the plan and the plan parameters. And there's also some base depths at the cell center. So it does a maximum depth, a minimum depth, and it plots your cell locations with depths greater than 1 foot. I know this has been really valuable to some of the engineers on just being able to identify where those are very quickly. And then we do have a computational summary. And this quality report does go through some velocity checks as well if there's velocities above the thresholds. And if you have a plan that has those will be included as well. So we have a lot of users who are using this report to help facilitate that quality report. And at the project level, we have review files. So those files can actually be uploaded here to be shared across the team. So they can come in and create these folders and upload their checklist and use that quality report to help facilitate getting there faster. One key thing in the quality report is really just allowing the engineer to identify global instabilities at this first stage that can be addressed before moving on to the review process. So it's really helping speed up some of our project delivery times on catching those things early in the process. We'll go back and look at our demo model output. So once the model kicks off, it will jump you over to this output screen where you can check the status of your model run. So here we're going through preparing the model data for parallel processing. So this is where it's getting the model set up and being able to process. And then we can come look at one that is already complete here. So in the output, there is a details tab. This is going to provide you metadata around the model run. So we have who completed the model run, information on how long that specific plan took to run. Since I'm using the Muncie model, this one's a base model from HEC-RAS and it's very quick to run. But this will actually take you through each step. And I have some examples back in our presentation we'll go through of where we've really seen major time saves in these projects. But we also have a help button here that you can use and the users can actually be able to look up how to run models, best practices, all of that information is easily accessible within the UI. We also have a standard output. So when the user is running the model, they can actually check the standard output, and it looks like this here. So they can actually look, and as the model is running, they will be able to tell at what stage the model is at. And it does track duration for you as that model is running as well. And then we also have the ability to, once the model is complete, to download the full model. We have the option to download a save as, which allows you to save somewhere external to your C drive. With these 2D models, we've seen a lot of really large model plans or model sizes. So being able to select to save that to an external drive or somewhere on the network has been really beneficial. We also have downloading the compute files only. So this is a subset of your model run that only includes the files that have been updated during the run. This was really key in helping us not have to download all of those really large terrain files and HDF files if you had uploaded them in the beginning. And so this is really just allowing you, if you are the modeler and you have the model locally, you do not have to download the full model. And then we do have downloading all of those QA/QC files as well for your plan if that was selected at the time of the run. Not only do we have all of these, but we also have a viewer, which is available at the top right here. And so if you selected to create those grids at the time of your model run, you can come into the Flood Manager viewer and you can select the model, the run of that model, and then your plan that you had grids created for. For the Muncie model, we have grids for 2 of the plans. We have a water surface elevation grid, a depth grid, and a velocity grid. So you can actually zoom in on these, and we have the ability to query these grids to get the values of the water surface depth or velocity. And I will jump back over to the presentation now. So really just recapping the major benefits of Flood Manager that we have been able to see in all of our project use is that we're really accommodating getting those models off of the user's workstation. So this is really helping allow the engineer to really do engineering work and not have to wait on models to be done. We also do have an email notification that goes out to the engineer. So whoever ran the model, they will get notified if there's an issue and the model cancels, they will receive an email. When the model succeeds, they will receive an email. So it allows them to not babysit the model and be able to work on their other project needs during that time. We're also seeing a major parallel processing speed increase. And I think the key piece is really when you have several models that you're trying to run at the same time, or if you have extremely long running models that have a lot of plans and you're able to speed that process up. This is also available on demand, so you can access it from any workstation anywhere in the world. So having the metadata there to be able to provide if your client asks information or if you're curious about the model, you're able to actually see who ran it and be able to have access to those staff for questions. And then really seeing that just the whole process of identifying those global issues early on and being able to address those early in the modeling process. This is an example of one of our parallel processing in action. And so we did have a project that had 6 storm events. They had 2 conditions for each. And so this model is actually 12 total plans. It took 96.5 almost hours, so 4 days for this model to run. In Flood Manager, our project team is able to run all of those in the same workday. So they can come in the morning, start that project, let the model run, and it took around 7 hours and 48 minutes. So really reducing major delivery timelines for this specific project. So next slide, please. This is one of our case studies, so Kansas 2D hydraulic modeling. This is that specific example that I was just talking about. Our internal team is using this to do their 2D engineering work, and this model specifically would have taken 59 hours to run. So for those plans to be run, each of them individually, I always like to give the guideline of whatever your longest running plan is, you can expect your model to finish in a few minutes after that. We do have that expand step and then the merge step at the end that take a few minutes. So all of your plans can be complete in a little more than your longest running plan. This is another case study. The Iowa Department of Natural Resources they are one of our, or Stantec is the project management team for this Iowa DNR client. So we actually have contractors that are using Flood Manager to get to those final models and are using that in their workflow to help speed up the quality checks and the QA/QC of each of the models. So one contractor can access the other contractor's model and be able to download those and not having to coordinate how to get those models transferred back and forth. And they're also able to store their quality checks in that review file folder that we saw in the demonstration. So this is really helping streamline that for that specific client. We're also working on a new product, so continuing to try to figure out how do we continue streamlining this workflow. And so we are in development on Model Manager, and this will be for the longer term storage of these large models. So Flood Manager is really about getting to our final model and assisting the engineer in really getting through their modeling process. Model Manager is going to be where we can store these models for the long term. They are, unlike other storage products that are available, we are storing those by watershed. So we're able to organize the files by watershed. This includes version tracking. Right now, we're supporting file categories of depth grids, water grids, so all those TIFFs that you have, the database, the model, and we even have the option for other files if there's relevant files for the project. We will have public APIs that connect into external viewers as well. So you'll be able to access those model data sets from external viewers and be able to download those. So just continuing to try to solve those pain points of what we're seeing with these really large 2D models. I think we're ready for questions.
Thank you, Brandy. I appreciate that. I'd like to see if we've got any questions out there from our audience. You can type your question in the Q&A section and it will appear and we will answer any questions that you may have. I'll start with something, Brandy, that you might want to tell people is the product available now, and how do they access the product, or how do they find out more information about how they might access the product?
Yes, so Flood Manager is available. We have on the actual link here that we'll send out following this presentation or this webinar, you can actually go to the site and request a new project be set up. So you can also get in contact with Susan or Catherine or myself to initiate starting the setup of a project. And I think we do have a question in the chat I see here. Are there any additional features that will be added to or available on the viewer? Yes, we do have in our upcoming version later this month. We have some post-processing for break lines, boundary lines, and 2D reference lines to be added to the viewer, and those will be available in our next version.
You can see some others coming in here. What HECRES versions are currently supported?
Yes, we have 507 through 6.3.1, excluding 6.3, but we are making that available in this next release as well. We have a project team that had that requirement, so we will be adding that version in, and we'll support 6.3.
Also, do you offer a free trial?
Yes, so we do have, if you would like a free trial, you can reach out and we can set you up with a trial account. The trial account does allow you to run one Muncie model or one base model, so you can get familiar with the system and learn how it works.
Brandy, you might tell our audience today a little bit about how we're even using this internally as well as externally. I thought that you did a good job with what we were doing with Kansas, but you might mention a couple of other projects where you've had some very large models to run and that sort of thing.
Yes, we do. We have another project internally that we are using to really help coordinate the data transfer of these large models. So I know we have one team that was having to put some models onto an external hard drive and drive those over to the contractor's office. So they've been able to set up a project where the contractors have access as well, and they're able to download and get access to the models from Flood Manager. So that's been really helpful in that project as well.
That's great.
Let's see, we've got how do you handle multiple users that may be from different offices or companies. So yes, same, once the project is set up, you can request any users be added to that project, so they do not have to be from the same company or in the same office. As long as they are set up on the project, they will have access.
I know that our users our participants are probably wondering about the pricing question. You might want to just address that there's multiple pricing options.
Yes, we do have a pay-as-you-go pricing where you can just pay for those model runs as you're completing them, and that's billed out monthly. And we do have a subscription offer as well. So if you're interested in finding out more about our pricing, we can send you a pricing sheet over, so just let us know.
Well, I don't see any more questions coming in. I want to thank all of our attendees today for taking the time out of your busy day to join us. We will have, as I said, the recording will be available, and we can get you also a certificate for your professional development hours. So I would also like to tell you about another upcoming webinar that we're going to be having toward the end of the month. We're going to do a flood predictor, which is our machine learning, probabilistic modeling, and that will be later this month, the 28th of this month. So be sure you can use this link right here to sign up for that if you would like for that. And we hope that you'll be able to join us. Again, if you have any questions, any further questions, or want some more information, feel free to contact myself or Katherine or Brandy. So with that, I will thank you all for your time this afternoon, and we will conclude our webinar.